Today we're working on how to solve quadratic word problems. So in order to do that, you have to actually know how to find the vertex of a quadratic equation, and you also need to know how to find the x-intercepts, and so that's what we're working on, okay? So we're going to learn how to do that by looking at the equation, okay? So we're going to start out by talking about how to find the vertex of a quadratic function. So you're going to be given an equation, and they're going to ask you to find the vertex, or they might ask it in a different way, which we will get to later, okay? So if they ask you to find the vertex, first off, remember that the vertex is a coordinate, so it's going to have an x and a y value. And then it's also the turning point of your parabola. So like if you look at it and it's graphed, it's that point where it switches directions on you, okay? And so that's the coordinate that you're looking for. So if it's not graphed for you and they give you the equation, like in this example down here, you're going to have a way of finding it, okay? So if you're not able to graph it, there is a way that you can find it by using a little equation, okay? So to find it, what you have to do first is you have to actually find the x part of that coordinate first. And so to do that, you have to start by making sure that your equation's in standard form. So remember, standard form for a quadratic is y equals ax squared plus bx plus c. So you're going to have to get it in that form first. So sometimes you might have to multiply stuff out. Sometimes you might have to rearrange the terms so it looks like this, but you've got to get it to look like that. And then you're going to figure out what the a and the b are. So if the a if you remember, the a is the number that's in front of your x squared. The b is the number that's in front of x. Okay, so you're going to figure out what those two numbers are. And to find the x part, the first number that's in your coordinate, you're going to use this equation right here. Okay, so that's the equation you have to memorize to be able to find or start finding the vertex of your parabola. Okay, so what you're going to have to do to find the x, you're going to take essentially negative 1 times whatever your b is, so times whatever that number is right there. And then you're going to take that and divide that by 2 times whatever a is, which is your number that's in front of the x squared, okay? So once you do that, then you'll have the x part of your vertex. So you'll have that first number that's in your vertex, okay? Then, well, what do you do to find the y part? Well, you just have to take whatever number you just got, okay? So to find the y value of the vertex, you're going to take whatever the x value was that you just got, and you're going to actually plug it in to the equation. So you're going to take the equation, and you're going to plug that x in, and when you plug it in, you'll get your y value. Okay, so like if you look at this example up here, we had to find the vertex of this. Okay, so if we weren't able to graph it, then what we would do is we'd figure out what the a and the b are. So a ended up being 1, and then my b was negative 2, because the a is the number in front of x squared, and then the b is the number in front of x. And then we plugged it in, so it's negative times b, so we took negative times, my b was negative 2, and then we put that over 2 times a. So it'd be 2 times, well, my a was 1. And then we simplified. So negative times negative 2 was a positive 2. And then it'd be 2 over, well, 2 times 1 is just 2. So it'd be 2 over 2, which ended up being 1. So that was the x part of my vertex. And then I took that x, and then I took my equation, and everywhere I had an x, I had to plug in my 1. And actually, this shouldn't be a square right there. This should be squared. So it'd be 1 squared minus 2 times 1, and then plus 3. And then you just simplify. So that would be 1 squared, which is 1. And then it'd be minus essentially 2. So 1 minus 2 was negative 1. And then if I take negative 1 plus 3, I get 2. So that was the y part of my coordinate, okay? So let's do an example so you can see how it works. So let's say that they give you this equation, and they ask you to find the vertex of that equation, all right? So if you don't have it graphed, then you're going to start by figuring out what your a and b are, and then you're going to plug it into the equation. Okay, so remember, we're looking for the coordinate of the turning point of that parabola. Okay, and so, well, your a, remember, is the number in front of x squared, and you could even write down your standard form right above it so you could see kind of where to pull the a and the b from. So the a is the number that's right in front of your x squared, which is -1, so that goes there. And then your b is the number that's in front of x, so that would be a 2. Okay, so then from there, you're going to take these two pieces of information and plug it in this equation. So I'm going to just copy that equation down, and I'm going to plug in. So to find the x part, I'm going to take -1 essentially times my b, which is 2. And then that's over 2 times, and my a is -1. So I'm plugging that in. And then I just simplify. So negative times 2 is -2 over 2 times -1 ends up being -2. So when I simplify that, I get 1. So the x part of my vertex ends up being 1. Okay. Now what do you do to find the y part? And actually we're finding the vertex, so I'm going to make sure that we know that. Okay. So to find the y part, like I said up here, to find the y value, you're going to take your x value that you just got, and you're going to plug it into your equation. So I'm going to now take this equation. Notice it's y equals that equation. I'm going to take that, and I'm going to plug in everywhere I see an x. I'm going to plug in what I got for my x value. So it'd be negative times, put parentheses when you're plugging in. So it'd be 1 squared plus 2 times 1 plus 1. And then I just simplify. So 1 squared is 1. So that would end up being negative times 1, which is -1. And then 2 times 1 is 2. And then that plus 1 comes down. So -1 plus 2 is a positive 1. And then 1 plus 1 ends up being 2. So that would be, it just happens to be the same vertex as that. It's not always going to be that, but it just happens to be the same. So that would be the vertex. So if you actually had to sketch a graph of this, you could now. Because if you remember, you could actually tell a couple things just when it's in standard form. So remember, that would be your y-intercept. And then this tells you if it opens up or down. So if the number in front of the x squared is negative, it opens down. So you can actually sketch a graph of this if you wanted to. So I know the turning point is going to be at 1, 2. So that's going to be right here. So I can put a dot there. I know that the y-intercept is going to be at 1. So I could actually put a dot right here because it's going to hit right there. And then I also know it's going to open down. And so that's the turning point. So I can kind of sketch. It's not going to be perfect, but I could at least sketch a picture of what that would look like. So that is how you find the vertex, okay? So now some other problems, you're going to have to be able to find the x-intercepts, okay? And we've actually already practiced this, but I just wanted to kind of review. So when they ask you for the x-intercepts, remember x-intercepts have other names, okay? So x-intercepts could also be called zeros or roots, or when they ask you to solve it or find the solution, those are also your x-intercepts, okay? So don't forget that. But the way that we found the x-intercepts, this is what we did when we were solving a quadratic. So go back to your notes when we were talking about how to solve quadratics, okay? But one way that you could think about it is you're actually finding where that parabola, where that U shape crosses the x-axis, okay? And so there were 3 different ways that we talked about how to find them. You could solve it by factoring, which is where you get it equal to 0, then you factor it, and then you set each piece equal to 0 and solve. You could do it by doing the square root method, which is where you have to start by getting the squared part by itself. And then you do the opposite of squaring, which is square rooting. And you have to do it to both sides. And then you have to remember to put your little plus or minus. Sorry, that kind of ran into the next part. But then you solve if it's needed, because sometimes you'll have to solve afterwards. And then the last part is you could solve it by graphing. So if you're able to graph it, you could graph it by making a table, or if you had Desmos available, you could use Desmos. And then you just look at where it crosses the x-axis, okay? And so you have options. And so, for instance, if they give you an equation and you have to find the x-intercepts, one thing that we could do is we could try factoring it. So to factor it, if you have it equal to y, you can actually put a 0 instead of y. And so I'm going to put a 0, but we usually put it at the end. So I'm actually going to just copy this down, and I'm going to put equals 0. And then if I was factoring, remember you look to see if it has a GCF first. So they don't have anything in common, so I'm good there. And then, okay, well, how many terms does it have? And it has 3 terms. And so to factor it, that's where you do the trinomial stuff. And so is it going to be one that's just a regular trial and error or a chin and grin? So if you look up here, it's got a 1, so that's a basic one, which is just trial and error. And so you ask yourself, okay, what times what gives me x squared? And it would be x and x, so that's what goes first. And then, remember, you look at the signs, so that last sign tells you what's going to happen. And so if it's a negative, that means automatically that you're going to have a plus in one and a minus in the other. And for these problems, you can go ahead and put it because it's not going to really make a difference. And then, remember, you go to the side and you list what multiplies to give you that. So we got 10 and 1, we've got 5 and 2, and that's it. And then you're going to look to see which of these combine with these signs to give you that middle term. So here we're trying to get a -3 out of it. And so think about how can you combine these or these with different signs that would give me -3. So if you kind of sit there and think through it, you'll realize that if I put this 5 with the negative and the 2 with the positive, -5 plus 2 is -3. Okay, so that we factored it. Now, to actually solve, that's where you take each piece and you set it equal to 0. So I'm going to take my x plus 2 and set it equal to 0. And then I'm going to take my other factor, which is x minus 5. I'm going to equal that to 0, and then I solve. So here I'd have to subtract my 2 to both sides. And so x would equal -2. And then for this one, I would have to add 5, so x would equal 5. And so your x-intercepts, it would hit the x-axis at -2 and 5. And you could actually sketch this one if you wanted to, or if you needed to. So look at the number in front of x squared. It's positive, so that means it's going to open up. You actually know it's going to cross the x-axis at the y-axis at -10, so you already know that. And you also know it's going to hit the x-axis at -2 and 5. So -2, and then 1, 2, 3, 4, 5. It's going to hit right there and right there. And now I didn't draw my graph big enough to be able to hit it at -10, so I'm going to just sketch it. So it's not going to be perfect, but that would be kind of like what it would look like. Okay, so you at least have an idea just by using your information that you found. Okay, so that is one way that you can find the x-intercepts, is by factoring. Another way would be to use square root method. So remember, the square root method only works when you're missing that x term, that bx term in the middle. Okay, so like notice with this one, if I had to find the x-intercepts there, remember I'm solving it, so if it's missing the bx term, I could use square root method. And notice it is missing that x term, so I could use square root method. So just like what I did over here where I put a 0 instead of y, I'm going to do the same thing here. So I'm going to bring down that part of it, and then instead of y, I'm going to put equals 0. And then I'm going to solve it using square root method. So you've got to get the squared part by itself. So notice my x is the thing being squared, so I want this 12 to the other side. So I'm going to add it to get it to the other side. So then -12 plus 12 is 0, so that goes away. And then I have x squared equals 0 plus 12 is 12. So then once you get the squared part by itself, this is where you got to get rid of the square. So that's where you square root both sides. So you square root both sides of your equation. And when you do that, that gets rid of the squared part, and you're left with x equals, and then whatever the square root of 12 is. So you can type that in because it'll be a decimal. So when you do that, you end up getting and we'll round it to the nearest hundredth, so 3.46. And then don't forget, there's actually two numbers that when you square them, it gives you 12. There's the positive and the negative. So you put a plus to represent positive 3.46 squared will give you 12, but also if I take negative 3.46 times negative 3.46, it'll also give me 12, okay? So there you go. Your x-intercepts would be positive and negative 3.46. So you could write it like this, or you could actually write it out. You could say, okay, one of my x-intercepts would be at negative 3.46, and then the other one would be at positive 3.46. So you could write it either way, and it would be appropriate. And then again, you could kind of sketch a graph of that one too. It would open up, it would hit the y-axis at negative 12, and then this would be where it hits the x-axis. So that is how you find the vertex and the x-intercepts.